Hello, my name is Grover Welch. Today I'll demonstrate how to conduct a Pearson correlation analysis in SPSS to examine the relationship between free, reduced lunch percentages and student math achievement. This analysis addresses a critical question in education equity. Does this socioeconomic status of students as measured by free and reduced lunch eligibility relate to their academic performance? Research question. A specific research question we are addressing is there a significant relationship between the free reduced lunch percentage and percentage of students scoring at the exceeding level in math? This question is important because it helps us understand how poverty affects student achievement. Assumptions. Before conducting the correlation analysis, I want to note that we are assuming all assumptions for performing a Pearson correlation test are met. These assumptions include both variables are measured by the interval or ratio level. Variables are normally distributed. The relationship between variables is linear, and there are no significant outliers. For the purposes of this demonstration, we are proceeding with the understanding that these assumptions have been verified. Now, let me walk you through steps to perform the analysis in SPSS. First, I'm going to open the data set, which is school statewide school district data.save. And so this is my data set here that I opened. Contains information from 235 school districts across the state. So in order to access the correlation data, I went to Analyze, and then I went to Correlate, and then I hit Bivariate. Then I selected Free and Reduced Lunch, and then I went down and selected Math Exceeding, and then I hit OK. So I selected the variables in my bivariate correlations dialog box. I moved two variables in, free and reduced lunch, math exceeding. I ensure Pearson was checked under the correlation coefficient section as we are conducting a Pearson correlation analysis. The test significance. Under test significance, I selected two-tailed because we were testing for a relationship in either direction, positive or negative, and I ran the analysis. Now let me interpret the output that SPS has produced. As you can see, in the correlations table on screen, the results show a Pearson correlation coefficient of R equals negative 0.696 with a significance value of less than 0.001. The double asterisk notation indicates that this correlation is significant at the 0.01 level using a two-tailed test. That means first, the correlation coefficient of negative 0.696 indicates a negative relationship between the two variables. This means that as the percentage of students receiving free or reduced lunch increases, the percentage of students scoring at the exceeding level in math tends to decrease. Second, the significance value of P less than 0.001 tells us that this relationship between the two, this tells us that this relationship is statistically significant. This means there is less than a 0.1% probability that this relationship occurred by chance. We can confidently reject the null hypothesis that there is no relationship between these variables. The analysis included data from 235 school districts, as indicated by the N equals 235 in the output table. Is this a meaningful relationship? The answer is yes, and I'll explain why. According to our guidelines for interpreting correlation coefficients, our R value of 0.696 falls into the strong range, and correlations between 0.50 and 0.70 are generally considered strong, and ours is at the higher end of that range. This tells us that approximately 48% of the variance in math achievement scores can be explained by the free and reduced lunch percentage, calculated as R squared equals 0.696 squared equals 0.484 or 48.4%. So APA style. In conclusion, this analysis reveals a statistically significant, strong negative correlation of R equals negative 0.696 with a P of less than 0.001 between the percentage of students receiving free or reduced lunch and the percentage of students scoring at the exceeding level in mathematics. This relationship is not only statistically significant, but also practically meaningful, accounting for approximately 48% of the variance in math achievement across the 235 school districts in our data set. So yes, the correlation strength is strong. Practically, this means that as poverty increases in a district, math scores tend to decrease substantially. This suggests that funding is necessary for these districts.